Hello, this is Mr. Weideman, Lafayette High School Functions and Trigonometry class, and today I am going to cover the last part of 6.5, solving trigonometric expressions. And this is where we left off on my previous video. We had these warm-up problems from the first part, and then that was your homework section. And let's see, we went over these warm-up problems. You can stop the video at any time and take a look at these, but like I said, they're in my previous video. And let's see, there was the last one. Oh yeah, and then if you want, there's homework problem number 29. Yeah, there you go. Okay, so let's get into the last part of section 6.5. And what is the difference between this and the first set of problems? And they're far more difficult. The idea is the same, that we're trying to solve, which means I need to isolate the trig function. Isolating the trig function is going to be significantly more difficult in these problems. And if you look at this first example, you'll see why. Well, which trig function do I isolate? Do I isolate the tangent, or do I isolate the sine squared? Take the square root of both sides. And the idea here is we're going to have to use our identities. When I say use our identities, I mean use all of our identities. Not just Pythagorean, but you're going to see some double angle in here, and you're going to see difference in some formula and stuff like that. Those are still identities that we can use to simplify this equation. All right, so the first thing we got to do, let's look at this example. We have to get everything in terms of either tangent or in terms of sine. Okay, so the temptation here is to divide both sides by tangent. And algebraically, there's nothing wrong with that. I mean, that by rules of algebra, I can divide both sides by tan x. But when I divide any equation through by a variable, I'm going to lose one of my solutions. So don't do that. It'll make you sad. Okay, so what I'm going to do now, you could, I haven't worked it that way, but some student says, well, what if I just made tangent in terms of sine and cosine? Would that work? And it might. I didn't do it that way. The first thing I did here, probably the biggest strategy that you're going to have on these more difficult problems is setting them equal to 0 and factoring. Okay, kind of like back in the day solving quadratics. What did you do? Set the quadratic equation equal to 0, factored it, and set each factor equal to 0. That's probably going to be the easiest way. All right, so that's how I'm starting off here. And, oh, this is exactly what I did. I factored. It is a quadratic, but it also has a GCF. So I factored out the GCF. Now, what we can do now is all I need to do is set the individual factors equal to 0. This is what we did way back, probably in September or October, when we were solving polynomials. We would factor the polynomials, and then we would set the individual factors to 0. So if I can get tangent x equal to 0, I found a solution. If I can get sine squared minus 3 to equal 0, I found another solution. Okay, so that's how we're going to do this. Okay, so what values of x will make tangent 0? Okay, we look on our unit circle. We know that the tangent of 0 degrees and the tangent of 180 degrees, or pi, is 0. All right, that's two of our solutions. Now let's look at this other factor. Okay, so I'm going to solve it. Let's take the square root of both sides. And is there any angle on the unit circle whose sine is plus or minus root 3. And you're looking at the circle and it goes, well, it kind of sounds familiar and stuff like that. I want you to think about something. Square root of 3 is about 1.73. What is the domain of inverse sine? It's -1 to +1. So this is not a solution. Okay, so there is no angle whose sine is root 3 or negative root 3. Okay, because the sine is going to go from -1 to +1. Think about the sine function. It fluctuates from +1 to -1. All right, so we just have two answers. Okay, let's take a look at the next problem then. Example using an identity and a trinomial factoring. All right, let's see what's going on with this. Okay, first problem is we need to get everything in terms of sine or in terms of cosine. All right, so what do? We need to plug in an identity here. This one's kind of tricky. Look at this guy right here, cosine 2x. That's a double angle formula. Okay, and how do I know that? Because I'm multiplying my input variable by 2. Okay, so now I do that, and everything is in terms of sine. Now this is actually a quadratic. Okay, let's use that double angle formula, and let's rearrange things here. We set it equal to 0, and that is actually a quadratic. It's kind of in the form -2x squared plus 3x minus 1 equals 0. It's not x, it's sine x. Okay, we're going to use a technique here. It kind of goes back to doing a composite. I could have two equations, and you don't have to write this down, just want you to follow along. Let's say I have, back in the day, let's say I had f of x was equal to -2x squared plus 3x minus 2. Okay, and then let's say g of x was equal to sine x. And what if I asked you to do a composite? F composite g of x. What would you do? Well, you would put this function into that function, and we'd get -2x squared plus 3x minus, oh Lord, sine squared x plus 3 sine minus 2. Okay, so we're going to borrow that idea, and what we're going to do is we're going to kind of make a decomposition here, and we call this U substitution, and it is kind of borrowing this idea of these composites. And as you get into upper level math courses, it's a very common technique. So you're going to see it for the first time now, but it's going to be something you're going to need to get used to as you advance in your mathematics course. All right, I cleaned this up a little bit by multiply it by -1. Okay, now watch what I do. This guy right here, I'm kind of going to make a decomposition of this thing. So how am I going to factor this? Well, I have to recognize it as a quadratic. And what I'm going to do is I'm going to let u equal, the ugly thing. In this case, it's sine x. All right? And I can factor that. Okay, that factors into 2 variable minus 1 times variable minus 1. Okay, in this case, what is my variable? Well, my variable is sine x. All right, and what I can do now is I have two factors here. All right, and I'm going to do like I did before. I'm going to set these factors equal to 0. And now I'm way back to where, oh, you know, this is easy stuff. This is the stuff that we did in the first part of the unit. Okay, so where does the sign equal a half? Okay, and where does the sign equal 1? And it says on the interval, and everything coterminal to these guys. Well, everything coterminal to these three solutions is going to be greater than the interval that they want me to find. So they want all solutions. They just want all solutions between 0 and 2 pi. So every single coterminal angle of these guys is going to be too big out of that interval, so I don't have to worry about it. All right, this is getting a little lengthy. Let's see what this last problem looks like. Okay, this is not so bad. What am I going to do? Let's use an identity, right? 2 cosine squared that's a Pythagorean identity. Let's substitute that in. Let's distribute the 2, and you go, oh, I've got a kind of a quadratic looking thingy here. And so I know how to do that. I'm just going to let u equal to sine x. Right? If you can see this as a quadratic and you don't have to do the u substitution, okay, more power to you. And this really looks a lot like the last example. Okay. So I just need to set the factors equal to 0. Just solve the factors for 0. And I'm going to get 1/2. And where on the unit circle is the sign equal to 1/2? 7 pi over 6. And 11 pi over 6. Where's the sign equal to 2? No place. Okay? That is out of the domain of the inverse tangent. So I just have 2 solutions to contend with here. Okay, fantastic. And let's talk about then our assignment. There we go. Okay, so this is the last assignment then for Unit 6.5, and that will be due the next time we meet. Okay. So, and there's some little hints of the format on to help you solve. All right, these are challenging. Good luck with it.